morning, everybody, to our very first booth talk at the 2021 ESCRS, and I'm very happy to have a very special guest and a year-long friend, Berkeley, Dr. John Bolger from the Manic Eye Clinic out of London. And you are going to talk about settings. And we all know from the industry that when we bring our products onto the market, we try to figure out what would be the best factory settings be. And with that, you get about, I would say, 70% of the surgeon. Then within the application, real work of the surgeon starts. And to really figure out what are the ideal settings for you in the clinic, to work on your patients, what is best and how to work with it and how to get there is what the talk is going to be about. And we're delighted with it. Thank you very much.
Thank you. Thank you. So, we're going to look now at sort of when you get your new machine or you start off in your new facility, it's likely the machine will be set at sort of factory settings, which are great for ordinary scenarios. And because when the machine comes out of the factory, they want it set up so that it doesn't do anything surprising. So you'll find that the way things react, the way a machine reacts, is very slow. It's controllable. It's very average, very medium, very middle of the road, which is great for these sort of changes. And they many manufacturers will have incorporated psychologists into the development of the machine, even down to choosing what color the screen is and the voice. It's usually a lady's voice saying quadrant removal. They're not going to say. My God, the capsule's. They don't want to frighten you. So the factory settings are very, very controlled and middle of the road, and they're ideal for when you use the machine first. So the first time you use a machine, it's probably best to stay with the factory settings, the factories that are in the device. Or if you're operating in a new environment or with a new team you're not familiar with, and so on. But probably best to stay with the ordinary settings. Or if you're a beginner, or if you're doing an easy case, factory settings are good. But the problem with factory settings is that it is limiting. It's a bit like saying, I bought a car, but I'm not going to go into third and fourth and fifth gear, because I don't need to. I can drive to work in first and second gear. Well, of course you can, but is that really what you want to do? And with factory settings, the machine is telling you what you can do rather than you telling the machine what you want it to do. So it's important to understand what the different parameters might be and what things you might want to change and what things you might want to keep as is. So if you want to take on more challenging cases and work with more precision, or if you want to work faster and safer, then over time, as you gain more and more experience with that machine and with that environment, you probably almost certainly will want to change the settings. So let's look at the things that we have in the machine and what we can change about it. So I'm going to go into a little bit of the background of the machine itself, so we can understand what things we can change. The piezoelectric crystal runs 21st century life. You all have about 10 of them around your body right now, i.e. in your phone. Without the physics of a piezoelectric crystal, we would not be able to do anything. That life would be completely different. And the characteristics of it is that when you compress the crystal, it generates a charge. When you stretch it, it generates the opposite charge. And vice versa. When you put a charge across the crystal, it contracts. And when you reverse that charge, it expands. So it can do both. So, and in the handpiece, we've got usually about six piezoelectric crystals, and they are continually vibrating with the charge. So this handpiece is driven by what's called a piezoelectric crystal, and it causes that vibration is what makes the tip move. And the more we drive it, the more the tip moves. The less we drive it, the less the tip moves. So you may want to change how well it moves for you. And people talk about percentage of power. The percentage of power of a phaco tip is basically At 100%, the tip is moving as much as it can move, as much as the physics will allow it to move. At 50%, it's moving half that distance. So you can control it by how much you push on the foot pedal. And so at 100%, it's moving about 100 microns, typically. And it's doing that at about 28,000 times a second. So 28,000 times a second, it's moving forwards and backwards 100 microns. Now, if you think about that, that is, at the end of its stroke, it's experiencing a G-force of about 250,000 G at the end of the stroke. So the tip is weighing about 2.5 tons in the end of the eye. It was quite an amazing piece of physics, but it's so controllable. So we don't always use 100% of the stroke length, except in certain circumstances. So we may want to adapt that. So, and the way the power is delivered is also controlled. So in foot position 3, when you're engaging in phaco power, you've got, the more you press, the more you get. So as you just go into position 3, you might be getting about 5% phaco power. So the tip is moving 5% of what it can move to. And you may have set the limit at 80%. So when you push all the way down on the foot pedal, you've got 80% of the movement, or you might have 90 or 60 or whatever you've set it at. So you can control how much the maximum movement is, and you control it also by how much you push on the foot pedal. So the more you push, the more you get. But and this is continuous. So as in mid position, you might be getting 50% phaco power, in which case 50% of the stroke length, and it's continuous. But that generates a lot of heat. So you need to be careful about how you use that phaco power. So it's best, in my view, to pulse that power. And when you pulse that phaco power, I guarantee you'll almost notice no difference. It's as effective, but much, much safer, much more cooler. So the stroke length is contained by the degree of foot pedal maneuver, and the pulse frequency is what you can adjust on the front of the panel. So you can adjust how quick and how slow the pulse is. But each pulse itself is also pulsed. So inside each pulse, you've got sub-pulses, which is called the cool time. So the cool time of 40% means that 40% of each pulse, there's no energy. So it's even safer. And you can increase that to 60% or 80% of cool time, so that the amount of energy you're using is much, much less, but it's almost equally effective. So you can really use far less energy than you require in the standard factory settings. And you may want to start to experiment with that. So, and you might, in another way of delivering phaco energy is called burst mode, where you set it to burst mode and you set it at 80%. The first burst is 80% phaco power, but the interval between the next burst is controlled by how much you push the foot pedal. So if you just enter foot position 2, you get very few bursts per second. The more you press, you get more bursts. And then at the bottom of the pedal, you have almost continuous power. So you tend to use this in a harder cataract, which we look at in a moment. And then the other thing we need to just briefly look at is the pump. The pump is how the material is removed, how the emulsate that you generate is removed from the eye, and that liquid is replaced. And there's loads of discussion about peristaltic pumps, Venturi pumps, and how they work, which we're not going to talk about, but basically it sucks. You know, all pumps suck. I mean, that's all you need to know. But Poiseuille's law is what's relevant. All the pumps obey this law, where you can see the rate of flow, Q, is proportional or is equal to the diameter, the viscosity, the pressure difference between the eye and the pump, and the length of the tubing. Now, the only thing you can change is the pressure difference, right? You're not going to change the diameter of the tube. So it doesn't matter, really it doesn't matter whether you've got a Venturi or a peristaltic pump. It's because the piece of cataract that floating around the AC has no idea whether or not it's a Venturi or a peristaltic pump. all it knows is that the flow is making it go in a particular direction. So you just need to understand how you want to control that flow. Right. So, and if you change the tip size or the tip dynamics, you will have an influence on the diameter. So just be aware that if you change the tip, you want to think about how you want the phagodynamics, the fluidic dynamics to work. But basically, it's the same principle. This is the formula that controls what you do. So how does that apply to changing the settings? So for me, what my technique has evolved into is that in what I call Phaco 1, or you might call sculpt mode, depending on the manufacturer, I have a very low flow so that I can go right up to the iris, I can go right up to the anterior capsule edge without any risk of aspirating them. I also have a very low irrigation, so the bottle height's quite low because I don't need a lot of fluid going in and out because my aspiration is very low. I have a high phaco power, so I have about 80 to 90% phaco power because in sculpt mode is when I'm going through the hardest part of the lens, the nucleus. That's when I want to dismantle the nucleus. In the bag, I don't want it in the AC, I want to dismantle it in the bag away from the anterior, the endothelium and the posterior capsule. And this allows me to go close, and I want a low vacuum setting. Now, in the peristaltic pump, the vacuum setting is merely the setting at which the pump stops. So I want the pump to stop immediately if I occlude by mistake. Now, in sculpt mode, I do not want to occlude. I want to just keep the port open. But if I did by accident occlude, I want the pump to stop immediately because I'm going to be working very, as you'll see in a moment, very close to the posterior capsule in sculpt mode because I want the whole lens to crack in one complete go. So I have these sort of settings in sculpt mode. So when I'm looking at the phaco power, in this sort of cataract here, I would certainly use pulse mode and with a high cool time, except that when I get to the nucleus itself, I want to use maybe continuous. So on the foot pedal, I just switch to continuous mode for 3 or 4 strokes until I get through the nucleus to the posterior epinucleus, and I'll then go back to pulse mode. So changing those settings makes it safer and easier. Whereas in this sort of cataract, which is a sort of chocolate brown luminescent cataract, I'll probably use high burst mode all the way through because there's no point in trying to use factory settings. Can't deal with this sort of scenario. Not without a long surgery time, which is not good for the patient. So I'd use continuous or burst mode for this sort of cataract. But once the lens is cracked, so now I've weakened the lens and I've now got it cracked. I want to change the settings again so that it's more appropriate for the scenario. So now the loosened nucleus quadrants to the port, I want to hold them on, so I want a higher vacuum, and I want a lower phaco power because most of the nucleus now is gone. So most of what's remaining now is just epinucleus and cortex, right? So these are the sort of settings I would use. So this is a typical case. I've left the bubbles in for a reason. So I call it phaco prosecco. It's where it looks like I'm irrigating with prosecco. Now you see I'm going close to the iris I have been, and now I'm going very close to the posterior capsule. And I'm using this very low setting, so it doesn't matter. I've now switched to a higher setting to get rid of the bubbles. I go back to the lower setting because that lower setting wouldn't remove the bubbles. And now I'm able to go almost all the way through to the posterior capsule without any risk, because if I do occlude, the pump will stop. So now I've got the quadrant in the middle, and now these higher settings, a high aspiration, high vacuum, to pull those pieces into the safe zone. At this point, I keep the tip in the center. I don't go out to the periphery because this is when it would get dangerous. So you can imagine with a high aspiration, high vacuum setting, if I catch that peripheral capsule, it's gone. So always in the safe zone, the technique. But if I stayed with factory settings at this point, those pieces won't come. They won't come to me. I'll be going out after them, and so on. So to match the irrigation to the aspiration is important. So you can see that Most machines use gravity, but some machines are using different technology. So basically, the irrigation should match the aspiration. And if you increase the aspiration, you might want to increase your bottle height, or some of these machines will automatically change the rate of infusion depending on the technology that's being used. And lastly, I just want to talk about vitrectomy. Eventually, you know, if you do enough cataracts, you're going to do anterior vitrectomy with capsular rupture. That's unfortunately an inevitability. But the factory setting is foot position 1, irrigation. Foot position 2, it starts cutting. And foot position 3 is the aspiration. And the reason for that is it's regarded as a safe feature, that you can't be aspirating without cutting, so you're not pulling on the vitreous base. I prefer irrigation, aspiration, cut, which can be changed in the settings system. So the factory setting is irrigate, cut, aspirate. I prefer irrigation, aspiration, cut. You'll see in this case, I've got a capsular rupture. I've still got a peripheral cortex, which I remove with the aspiration mode without cutting, because if I try to remove that with cutting, I may cut the anterior capsule, and I'm now relying on the anterior capsule to support the implant because the posterior capsule is ruptured. So you can see here, vitrectomy, vitrectomy, vitrectomy. On the audio, you can hear the high-pitched beep, 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 meaning that there's occlusion, so there's vitreous in the port, and eventually that beep, 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 beep comes down low, meaning there's now no more vitreous. At this point, I begin to see, now this is just foot position 2, back to foot position 3, because there's still vitreous, and I'm now able to change by controlling the foot position 1 and 2, 3, I'm able to decide when I want to go out and remove that cortex, which you'll see in a moment. So I stop the cutting, but the aspiration continues. Now it's just aspirating, and now I can remove, because there's no vitreous now, so I'm not putting on the vitreous base. Just make sure, and then try that piece. Still, it's reluctant to come, but now I'm not cutting, so I'm not risking cutting the iris. I'm not risking cutting the anterior capsule. And eventually it comes, and there's no vitreous traction because I've removed all the vitreous by a core vitrectomy. So by deciding I don't want the factory setting of irrigate, cut, aspirate, I've been able to use the technique that I want to use. You may decide that's something that you want to stay with irrigate, cut, aspirate, but you may decide you wanted this as well. So it's being able to make those decisions is what's part of learning and moving forward from factory settings to your own settings. I mean, it's where you can set, this machine can do all of the things that you would see on other machines. It can do dual linear, it can do all the foot pedal. It can change from the settings from phaco 1 to phaco 2, which is sculpt, quadrant removal, epinucleus, all that sort of thing, all on just simple your own control, or the nurse can do it with a remote control, depending on how your preference is. So it's once you understand what you want to do with the surgery, the machine, most machines, but particularly this machine, will allow you to be able to evolve your settings. So you move away from factory settings into your settings and your technique. And then over the years that follow, you'll find that you will emerge as your own surgeon and become, I can look at a video and I can tell if it's me that's operating. Even if it's 5 years old, I can look at that video and say, that's me, or it's not me, because my technique is so specific to my own evolution as a surgeon. So I think all of us should know how the machine works, and how to change those settings. So you may say, I think I could like a little more aspiration, or I want less aspiration, or I need a higher vacuum to pull these pieces, or I'm getting too much capture, so I want to reduce the vacuum, or reduce the aspiration, or both, and so on. All of those things you can decide which settings you want, and most importantly, these last two is that no matter what machine you use, it will fail at some point, and you will need to know what's wrong. Is it the eye? Is it the machine? Is it the nurse has pressed the wrong button? Or is there something you need to rectify? And by understanding how the machine works and what technology you're using, etc., you will be able to say, there's something wrong, something's not right, And I'll give you one last example before we finish. I was operating with this model of machine, and I was getting quite an unstable AC. And I said to the nurse, I said, is the bottle at the usual height? And she said, what do you mean? And what had happened was my usual nurse was on holiday, and she was this height, and her locum nurse was this height. So she wasn't able to put the bottle up to my normal height. And I could tell there was a difference, right? And I would like to think that you guys, if you're not there already, will get to that point where something is different and you can tell before it does harm to the patient or makes it more difficult to do your surgery. So understanding all the things we've talked about and incorporating them into your technique, slowly, you'll be able to move away from the factory settings and evolve into your own technique and your own sort of characteristics of you as a surgeon. So that's all I want to say. I'm happy to take any questions, and good luck from here on. Thank you for your attention.